So we're now on to what we call vector norms, and we're actually going to work on two norms. So we're going to define a two norm, the two norm of a vector. And we're going to call this the two norm of a, we'll call it for now, column vector. Right? Could you guess what we need to start this definition? Yeah, go ahead, Mason. Okay, yeah. Could you guess what we need to start a definition of a two norm? Let x be equal to in Rn. Then the two norm of x is written like this. It's the two norm of the vector x. As a quick reminder, what does x look like if it's a column vector? x1, x2, all the way down to xn, and this is an n by 1. The two norm is going to be the square root of, can anybody guess what I'm about to say? x1 squared plus x2 squared plus x3 squared plus, what's the last one? xn squared. How did you know that it's ended with n? Because it's Rn. What does that immediately imply about the square of the two norm? That it's x1 squared plus x2 squared plus plus. Okay, you're a little faster than old Anderson. You got to slow down for this old feeble mind of mine. What is this right there? And maybe I'll have Samantha help me with that. What does it mean to do x1 squared? You're doing really well. You're always doing so well. You like do 50 things at once. You amaze me. It means x1 squared means what? x1 times x1. What does x2 squared mean? So now you've got x2 times x2, and then we go all the way down to all right. What do you notice about that? And what I might have you do is look at this expression and compare it to the definition of an inner product. First coordinate of the first vector multiplied by the first coordinate of the second vector plus second coordinate of the first vector multiplied by the second coordinate of the second vector plus first nth coordinate of the first vector times the nth coordinate of the second vector. What's the first vector in this case? What are the components of it? Yeah, and this is what you were saying, right, Omer? Your teacher finally caught up to you. But you've known you're faster than me from the day we met, right? A few days after that. Yeah. Okay, and then what about this one? What is that now? Guess what you just discovered for yourselves? That's called the inner product formulation of the square of the two norm, or the inner product version of the two norm. Strictly speaking, what is the two norm? How do I write the two norm? Read it with me. We should read it in English. How do I read this thing? Of x. Yep. Equals the square root of the sum of the squares. Claim this number 2 is related to these numbers there. So 2, 2, 2, 2, 2. Could you guess what a 3 norm is? Sorry, there were two. So I heard many people say the cube root of the cube, and then you asked a separate question, which was what?
So I'm still kind of confused. What's the? You know how you did the 2 and 2 over there in the bottom, and the 2 in the first one? Yeah. So what does the bottom one imply?
That's what I'm describing right now. It just implies that the index of your radical is a 2, and that the exponent on each of the coefficients is a 2. So the 2 norm is kind of interesting because it's taking the square root of the sum of the squares. The 3 norm would take the cube root of the sum of the cubes. Could you guess what the 4 norm would do? The 4th root of the sum of the fourth powers, right? Yeah.
Do you call it the index of the radical?
Yeah, this thing up here is called the index, right?
Index of the radical.
Index, yeah, that's called index. And then this thing right here is called a radical symbol, and when you say it, you got to say, it's a radical symbol, right? And then this thing inside, you know what we call that thing? It's the radicand. And you got to use that voice when you say it, because that sounds real nerdy. Right, Marvin? Doesn't that sound nerdy? Okay. All right, so that's vector 2 norms. What I'd like to do is talk about the property of 2 norms. Yeah, go ahead.
Why or why can we not write it as x, the vector x squared?
Because define for me what it means x squared. What does that mean?
X times x.
What is times? There's no such, yeah, so I'm going to say, I guess this is a separate question. So you're asking me, he just asked me, so warning, danger, danger, high voltage. You can hear Jack White. Didn't he sing that last song? I forget. No. So let's see. If you write x squared, I will go to the president of the college and tell her to fire me. If I let you get out of this class and you're using squares of vectors, I should be fired. There are such things. There's something called a Hadamard product. There's something called a Kronecker product. I used Kronecker product very, very heavily in my PhD. And I can be cavalier and say that the square is the Kronecker product of x with x, or the square is the Hadamard product with x with x. But if you write to me x squared, and what you mean is x inner product x, I will petition the president of the college to fire me, and then my wife and my son and myself will be homeless on the street. Are you sure you want to do that? Do you want to cause my homelessness? Don't say yes. There's no such operation of a square of a vector if we're talking about inner products. Inner product should have its own space. Some mathematicians like to write this. They'll just write x, x. There are a bunch of other mathematicians, Ket and Bra, right? They'll write it like this. But in this class, I will adopt x inner product x. How would you have known that this is an inner product and not a scalar vector product? Yeah, that's called dimensions. So analyze dimensions until you're blue in the face and then keep analyzing them. The way I would have known that this is an inner product is the thing on the left has size n by 1. The thing on the right has size n by 1. Therefore, it cannot be a scalar vector multiplication, and it can't be a vector vector multiplication. How did I know it can't be a vector, or excuse me, a matrix vector multiplication? Inner dimensions don't agree. Darn it, right?
Are these vectors in subspaces?
Yes, but we're not there yet. Yeah. So analyze the dimensions, and then that deals with that question, I believe, right? Can I erase this so I can use this board without having to do all that shifting? It's a great question, by the way, because I've had that problem, like at least 5 students every quarter put that on the final. And every time that happens, I like grab a thing of tequila and I like kill the pain, you know? I'm just kidding. I don't drink while I'm grading. I think it would be really fun if I did that, but I don't drink at all, so.